What is up? It's your boy the Canologist, and we're going to be doing find mode in binary search tree. So this is probably the find function, which we're going to do. Given the root of a BST, return all the modes, the most frequently recurred element in it. If the tree has more than one mode, return them in any order. What is a mode? Value that appears most often. Okay. Oh, because like the easiest way to do this would be just traverse the whole array, add all the node values to that array, and then just find the one with the greatest value. Okay, so let's just do it my way first. LST is equal to this, or else we call it stores, as I usually do. Node array if node.left equals none, node.right equals none. If we get a root node, leaf node, I mean, return. so I pass in ARR.append node. If node.left, if node.right, you call helper. It's just wherever you put the append, doesn't matter. This is pre-order, post-order, in-order. So if there's a left, return, traverse. So now it'll fill up the stores array. As it goes through, then I just go stores. Sort. Stores.sort. Find array item with most occurrences, Python. Most common. Counter list 0. Okay, so you just do a counter. Oh, it's got a built-in mode. Import statistics. From statistics import mode. So I have my stored array that's sorted. Now I have to find occurrences, which is like the most of each. So I'll just do that here. just use space for I in stores. With final I not in stores. Final I plus equals 1. So if it doesn't exist in so if I from stores is not in final, the dictionary, final I equals 0, final I plus 1. So create the dictionary entry and then increment it. And then so largest equals none if for I in stores, then we go for I for if I not in final, final I 0, for I for J in stores. For I in stores, I not in final, final I plus 1. Then I have to get the key with the highest value. So let's put find key with largest value. Oh, I just do max. Because you could put an iterable in there. Max key equals stats.get. So return the max of stores is the iterable, so max method is the easiest way to determine a Python dictionary's maximum value. Okay, cool, perfect. That's exactly what I'm looking for. List dictionary. I don't like the way this is written. Dictionary maximum value. Yeah, so max d items. So list items and then you go key. Okay, so you can go values. Get the max value of a dictionary. Okay. Get the maximum minimum key. Max D gives you E. Get the key with the maximum value. Yes, this is what I'm looking for. Get the key with the maximum value. So max, this is the iterable. Stores. And then I go key equals stores.get. Key equals stores or final dot get. That returns the maximum value. Oh, dot node. Let's call it node val. Array.append node val. Node left. Node right. And you keep appending as you traverse. Start with the root node, append that. Oh, final. That's why I'm iterating through a dictionary, not the stores. Okay, that's weird. Let's, what time am I at? 22 minutes. Okay, let's just do a quick check, see where I'm going wrong, and pivot. My code fix my code the way I wrote it. Should be really close. Looks like you want to find the modes. Your current mode has some issues, need addressing. Collects all the node values in the list, but does not accurately determine because it relies on sorting and counting values separately. Okay, so let's also add the case of a single node tree. So if this is the in-order traversal. If not, node return, boom, else. Also, instead of the dictionary, it creates the dictionary directly, which is fine. Oh, okay. So what's happening with my code is I'm doing everything correct. It's just that it doesn't handle cases where this maxed off final should actually just be maxed out values. I want to find the highest values, then get the key. So for example, max D values. So I'm going to do that. Okay, there we go. So now I'm getting here root 1, 2. Max val equals max D values. So it's gonna be max final values. So it's gonna it's gonna traverse final, get the max value. So D values, final dot values. So now I get the max val, and then for max list you're gonna return it in any order. So max list append. I'm just gonna append this. So basically I'm gonna go through, create the dictionary entries of key values. So for that value, find out how many. So if it's 2, it could be 2. And then return it as an array. And then return max list as an array. So any item with this frequency will be returned. So val, max list append. And then I'm going to return the max list. So if it was like 1 null 2 2 3 3, it would return 2 and 3 in a list. Oh yeah, max list dot append key, because you're going key value pair. Output 1 2. That's weird. It should return everything. I do that. What was wrong with my code specifically? So your solution is wrong. Your helper function is not performing an in-order traversal, which is essential for BSTs. Okay, what's wrong with the helper function? Fix just this part. This case, okay, so my shit is right. If node is none, return. So if node is none. So we're gonna go if node is none. I think that's gonna fix it. That's the thing. I'm not checking for the node.left, node.right. This should fix everything. It was the in-order traversal that was not correct. This is like a pre-order or some shit. But basically what I was doing was I'm trying to get to a leaf node and then check left or right, right? But it's not checking if the node is none. If the node is none, then you could just return, because we're going to go to that node. So if we go to none, return. So if node's none, return. Node's thing, boom, then we go back. So this solves the issue with the node is none. So what I did here, let's submit it just to show that it's working. Boom. And I beat 41.40% of other solutions. So this is basically what I did. I said screw the space. I'm just going to use whatever I want. So handle the base case. If it's just the root node, return the root value directly. Then I create a helper function to get a list of all the node values. So this is basically a traversal. I don't care if it's pre, post, or in order, because all I care about is getting the list of the nodes. That's why I'm sticking array.append node value, right? So if I go array.append node value, right, that's going to fill up the stores list. So now that I have the stores list, I'm going to create a dictionary called final. This dictionary final, if the entry, I'm going to go through each element in my list, and if it doesn't exist in the dictionary, I'm going to create the element and add one to it. So I get each key, so each dictionary item, and how many times it showed up. All right, then I'm going to go max val. So I'm going to find final values, the max amount. So the key with the highest value, right? Because there could be multiple with the same highest value. I just want to find what that value is first. And then I'm going to create another for loop, go through each key value pair in my dictionary. If the value matches that max value, add it to the list for max list here. And then I just return the max list. So if like I have one, so if I have like, let's say 1 null 2 2, it's going to return 2 because the max value is 2, right? And 2 only number 2 has that. If it was 2 2 2, the max value is 3, so I'd return 2 because it has that max value. If I had 2 2 2 and 3 3 3 in there, I'd return 2 and 3 in my max list because they both have the max value. So that's how you would do this problem. And yeah, passes the test and submission. So if you like that, please give it a thumbs up, subscribe, comment below. Knologist out.